Okay. So we have the equation log base 2 of 8 equals x plus 3. What do we need to do to solve this equation or to solve the equation? Yeah, okay. We start all over. I'm going to solve this equation. How do we solve this equation? Well, we use the fact that the log base b of x function is inverse to the b to the x function. This means, among other things, log base b of a equals c is equivalent to b to the c equals a. Now we can prove those relations are inverse, but we're not going to do that. We're just going to use these to solve some equations. Okay. First thing we want to do is identify B, C, and A in this equation. Well, before we can do that, we got to just determine which of these forms we have for this equation. If any, in fact, I could always write an equation down. It isn't in either form. Then you're going to be kind of stuck. It's not in this form because there's no LOG. There's no log of anything here. So by default, it's in this form. But let's just be sure it really is in this form. This is the form b to the c equals a. Okay. Is this in the form something to a power equals a number or some other quantity? Okay, well, yeah. If b is 2, c is your x plus 3, and a is your 8, then this is in this form. So b is 2, c is x plus 3, a is 8. So the equivalent equation is this. Why? Because this is equivalent to this. Once we've identified b, we can put it here. So we have a log base 2. We identified a, it's 8. So that's going to be 8. And c is x plus 3. So we have an x plus 3 here. So that this translates to this. We don't want to skip that step until we're very confident. We always want to be able to go back and do that. Okay, well, having done this, what do we do next? Well, we need to use one of the rules of logarithms, which I've written down here. And the rule you need in this case is this one, log base b of alpha is log of alpha over log of b, or natural log of alpha over natural log of b. So x plus 3 is log of 8 over log of 2. Because, of course, this is log base b, log base 2, and the b log of b goes in the denominator. And then the alpha is 8, and the log of alpha goes in the numerator. Well, if you use your calculator, see this is 0.903, this is 0.301, rounded to 3 significant figures. And of course, that's equal to 3. So x plus 3 is 3. So x is 3 minus 3. X is 0. There we have it. Now, there's much more I'd like to say about this, but right now we're just scrambling to try to get this material down so we can pass this very fast-paced course, to which this course is the support course. Okay. So the next question is solve this equation. Okay. First of all, figure out which form it's in, identify A, B, and C, and then write it out in the other form and see what you get. Okay, well, we identified the form, we identified A, B, and C. B is 2 because it's a log. So it's a log base 2. There's your B. Of A, So here's what you take in the log of, it's 3x minus 7. The other side of the equal sign, got 4. The next step is to take this and put it into this form so you can access the variable. So let's see what we got there. Okay, I do believe we've got it. Let's make sure. Okay, B is 2, so B goes there. There's 2. Raised to the C power, C is 4, equals A, which is 3x minus 7. Well, no idea how to solve this, but there's very clear how to solve this, right? You can't just look at this and solve it. Oh, maybe you can. You can evaluate C2 to the 4. Okay, don't do that now. Write these forms down. Make sure you know, right? Okay. L2 to the 4th is easy. That's 16. That's 3x minus 7. You add 7 to both sides. So that's 23 thirds. You want to write that as 7 2/3, that's fine. But that's all there is to that equation. Okay, let's try the equation 3 log of 4x plus 2 equals 5. What we're going to do here is this in one of these forms. Well, you see it's got a log, so it would have to be in this form. But it isn't quite in this form. Like, you got this 3 here. It doesn't fit this form. And what are you going to do about that? Well, it turns out there's something very easy you can do about that. You can divide both sides by 3. Okay, well, divide 3 by 3, you get 1. So you just end up with log base 2 of 4x plus 2 equals 5/3. Now it is in this form because you can identify your B, you can identify your A, you can identify your C, and now you've got everything in the equation, so you can convert it to exponential form. Okay, so got it in this form. Well, we can identify our B. Our C. Our B and our A, our C. Okay. And now we can write this form, which is 2 to the 5/3 equals 4x plus 2. Okay. Now, 2 to the 5/3 is not something we can express exactly. So that's all right. We're just going to keep calling it 2 to the 5/3. Now we're going to subtract 2 from both sides. So we get 2 to the 5/3 minus 2 equals 4x. Make sense? And then we get x equals 2 to the 5/3 minus 2 equals 4. This is your exact solution. Now you could express that maybe a little more elegantly, 4 to the power of 2. I'm not going to worry about that because usually that's not going to happen. Okay. Now we can approximate this. What's 2 to the 5/3? Well, that's a 1/3 power of 2 to the 5th. And the cube root of 2 to the 5th. Which is cube root of 32? Cube root of 27, we know is 3. Cube root of 64 is 4. So it's just a little over 3. So that's like, I'm guessing, let's see, cube root. Yeah, maybe 3.1. Okay. So replace this by 3.1, we got the minus 2. 3.1 minus 2 is 1.1, 1.1 divided by 4. This point 275. We'll just approximate that by 0.28. If I did that right in my head. Now, yeah, I kind of think it's fairly close. 3.1 is fairly close. Of course, naturally, we're going to do this on a calculator and get a much more accurate approximation up to the 5/3. Okay, so let's consider this equation. Now, one thing, log of x plus 3 is not the log of x plus the log of 3. Can't do that. There's no rule over here that allows it. Matter of fact, the log of x plus the log of 3 would be the log of x times 3. Okay? And that's not the log of x plus 3. X times 3 is not x plus 3. Whether you understand that or not, what you need to do is match this expression up with one of these, because clearly this is not in one of the two forms that we're dealing with. It's not this, because there's only one log on this side, right? It's certainly not this, because there's no log in this equation. Okay. So we identify that we can't use those forms just yet. But we have a rule that allows, and you saw the rule. Okay, when I said this. You said that, okay, well, this matches this, right? Then you were a little hurried to write it out, and you didn't write it out correctly. So you want to do this step by step. Don't get ahead of yourself. Okay. This is this form if alpha is x plus 3 and beta is x minus 2, right? Because right there's the form right next to the expression. We can clearly see what alpha is and what beta is. I don't worry about x minus 2. Oh, yeah. Log of alpha times beta is 5, right? That is the log base 2 of x plus 3. And you better have parentheses around that x plus 3, because if you don't, you're not going to be multiplying alpha by beta. So alpha is x plus 3. And of course, there's a law. And now we've converted, or we've got this thing into the form. Log base b of, this is the same letters I use, a equals c. B equals 2. A equals x plus 3 times x minus 2. And c equals 5. Okay. Now this is equivalent the B to the C equals A. Going to be 2 to the 5th equals x plus 3 times x minus 2. Okay, so see if the equation is 2 to the 5th equals x plus 3 times x minus 2. Totally equivalent to this equation. Multiply this out. Use the distributive law. X times x minus 2 plus 3 times x minus 2. 2 to the 5th is 32. Because x plus 3 multiplied by something is you multiply by x and you multiply by 3. So it's x times the x minus 2 and the 3 times the x minus 2. Then we multiply x times x minus 2. That gives us x squared minus 2x plus 3x minus 6. And that's 32. So now we have x squared plus x minus 6 equals 32. Now how do we solve this equation? Okay. So our equation then is x squared plus x minus 6 equals 32. You got to recognize something. Oh, wait, aha. This is a quadratic equation. Okay. Got squared x, it's got an x, it's got a constant term, right? Got a couple of constant terms, we'll deal with that. Okay, so we need the standard form in order to solve the quadratic equation using the quadratic formula, which you remember quite well. Okay. Not sure whether what I heard was totally correct, but it was it might have been. Didn't hear it all. I heard enough. I know you know what the quadratic formula is. Okay, so, and that's good. But we've got to recognize when we have a quadratic equation, it doesn't do any good. It's not in that case. Okay. So how are we going to get a 0 here? Well, you said, okay. Made a good suggestion. Subtract 32 from both sides. Giving us x squared plus x minus 38 equals 0. Now, there's a natural tendency to want to, get the numbers on one side and the x's on the other. But since that would leave you an x squared plus x equals some number, it would help. Okay? You can't do anything with that. But with this, you can. Now, I'm going to remind you what the quadratic formula is, which you pretty much know. It tells you then that x equals -1 plus or minus the square root of 1 squared minus 4 times 1 times -38, all divided by 2 times 1. And if I did my arithmetic right, and check me, but 4 times 38 is 152. That's 153 over 2. And so on. You can simplify. You can approximate the solution, or you can write it out as exact, depending on the situation.